Hello, and welcome to the live stream of the first Ariane 5 launch of this year. Of course, Ariane 5 is the workhorse launch vehicle of Ariane Space, which is the European launch provider. And today they're going to be launching a couple of satellites that are going to be going into a geostationary orbit. And so we're going to get to see a little bit about that mission. We're also going to get to learn a little bit about the Ariane 5 vehicle itself, and maybe also a little bit about the missions that are flying. And we'll also talk a little bit about Ariane Space's development plans and, of course, their inevitable switch over to the Ariane 6. The Ariane 5 is going to kind of be phased out, hopefully, over the next year. This is one of the last launches, actually, that Ariane 5 will take. I think there's only one or two more that are slated on that rocket, and then it should all be switching over to the Ariane 6. So we have to enjoy the Ariane 5 while it's still there. Yeah, so we're just waiting on we're going to be waiting on the main cast for probably 10 or 15 minutes here. The launch is officially said to be going at 9:03 UTC, which is going to be in about 40 minutes. So T-minus 40 minutes right now. We do have a launch window of about an hour and a half today, so it might not necessarily go right at 9:03. If they have a hold or something like that, they can always push back within that hour and a half time window that they need. And also, of course, guys, keep in mind that if you want to ask questions along the way, go ahead, feel free. I'm happy to answer all questions about rockets and space. A little bit about who I am. My name's Josiah. I'm a space engineer at the University of Bremen. I'm doing a master's right now in space engineering. I'm also the chief engineer at Amateur Rocketry Association in Bremen, which is associated with the university. And we're trying to build a rocket to go to the Kármán line. So right now we are in the process of testing, designing, and building a rocket which will go to space as well. Not quite as impressive as the Ariane 5 maybe, but for our level it's certainly hard. So without further ado, I'd like to get into a bit of a discussion about what vehicle we're going to be seeing today and some of the interesting things about it. So the Ariane 5 is a vehicle which has been specifically designed mostly to service payloads that go to geostationary orbit. So basically the parameters that you see here are basically designed to achieve that specific task. So it's not necessarily the tallest rocket, it's only about 52 meters high. It's got a diameter of 5.4 meters, which is really interesting because that allows them to really be able to take some bigger payloads in terms of volume. I think it has one of the biggest payload bays from a volume perspective. It also has a pretty high takeoff mass at 777 tons. And the interesting part comes to the payload capacity that it has to LEO and GEO. So the difference between low Earth orbit and geostationary orbit is basically altitude. So in low Earth orbit, you're only orbiting at about a couple hundred kilometers in altitude around the Earth. But if you want to go to geostationary orbit, you have to end up going about 36,000 kilometers away from the surface of the Earth. So it's really, really high up there. And the reason why this place is interesting is because it's the location in orbit where you orbit at the same speed as the Earth spins. So from the Earth's perspective, you kind of hover over one spot. And this is really useful for communication satellites because, if you point your antenna at it, it'll never move. So you can just point your antenna once and you have connection and it all works. So that's kind of the niche purpose that this has. So Ariane 5 is specifically designed to get large payloads all the way to geostationary orbit. And that's exactly what you're seeing here as the stats for the vehicle. Next up, I just want to talk a bit about the different pieces of the rocket, because it says here there's 2.5 stages. So yeah, 2.5 is maybe a bit weird. Some people show this differently. They'll say it's just 2 stages, but from my perspective, it's 2.5 stages. And I'll explain why. So first, we have the core stage. And this is basically the bottom center of the rocket. And this is going to be running on liquid hydrogen and liquid oxygen, which is, of course, the most efficient fuels that you can use in modern rocketry. So this really allows it to have some good performance. The whole stage is about 23 meters tall. Again, the 5.4 meters width. The engine that's powering it is a gas generator engine. And so that's a specific type of cycle, which I'll go over a little bit later. It also has a thrust of 1,140 kilonewtons, and of course a really good ISP at just over 400 seconds because of the hydrogen oxygen that it's burning. It burns for a really long time, 605 seconds. So this really is going to make the profile that you see of an Ariane launch much different from other launches. Basically, most launches of other vehicles that are running on RP1 and liquid oxygen will only burn their center stages for about 4 or 5 minutes, and then that's it. But the Ariane 5 is, of course, running on hydrogen, so it burns much, much longer. And it nearly gets itself all the way into orbit just with that first stage. So that's really cool. The next part of it, though, is the boosters. So this is like, think of the core stage as stage 1. And the boosters are kind of like stage 0.5. And this is where the 0.5 comes from. So they're also connected to that core stage, and they're going to be separated from that core stage. So it's calling it all of those pieces just one stage is kind of not really true in my opinion. So I like to separate them and say there's kind of like a half a stage with the boosters. So these boosters are solid boosters. They're running on ammonium perchlorate, aluminum, and HTPB, which is a common solution for solid propellants. This is basically the same stuff that the space shuttle main boosters are running on as well. And that gives you a pretty good specific impulse at about 262 seconds. So, but the reason why they have these is because the Vulcane engine that's on the core center stage is actually not able to push the rocket into space on its own. So like it doesn't have enough thrust to even lift itself into the air. So it needs these boosters on the side just to get it going because of how heavy that core stage is to start. So that's kind of the reason why the boosters are there, just to give the Ariane 5 a bit of a push at the start. And you'll notice that the Ariane 5 really takes off fast off the launch pad. So yeah, blink and you'll miss it. Yeah, so that's enough said about the boosters, I would say. Then we come to the upper stage, which is the second stage of the rocket. This is also running on hydrogen and oxygen. It's not really too big, just 4.7 meters long. But again, that 5.4 meter diameter, which is really the key to the marketability of the Ariane 5, which is that they can really contain large volumes. Its engine, the HM7B, is one of the most efficient upper stage engines at a specific impulse of 446 seconds. This is, again, because of the hydrogen oxygen that it's running, and it gets a little bit better than the Vulcane engine just because, of course, it's vacuum optimized. And in the expanse of, when you expand the gases into space, you're able to get them going a little bit faster, which gives you a bit more efficiency. And again, because this is a hydrogen oxygen second stage, it again burns for a really long time, almost 1,000 seconds, which is like, how much is that? That's like 16 minutes. So it's really a long launch because you have a 10 minutes for this core stage and then 16 minutes for that second stage. So it's like 26 minutes altogether, making the Ariane 5 one of the longest launches that you can watch. But in comparison, a Falcon 9 launch is like half the time. So it's really, the hydrogen really changes the game a little bit. So let's get into a little bit of what the gas generator engine is. Here we have the gas generator engine I'm talking about. So basically, you have your fuel and your oxidizer represented by the orange and the blue, and those are fed into the combustion chamber by these pumps, the fuel pump and the oxidizer pump. But in order to drive those pumps and make them work so that you can keep pumping the fuel, how do you power that? Well, the way a gas generator does that is by taking some of the fuel in the oxidizer and burning them in what's called a pre-burner, and then using the exhaust out of that pre-burner to drive a turbine, and that's the black circle in the middle there. And that's on the same shaft as the pumps, and that's what basically spins the pumps so that you can keep pumping the fuel and the oxidizer into the combustion chamber. What you'll really notice on the Vulcan engine is that it has these like two exhaust ports that come down each side of the nozzle, and that is the exhaust out of the preburner that the Vulcan has. So look out for that, as it's an interesting part of the rocket. So what should we expect in terms of how this rocket will operate? Basically, there's a staging sequence that it goes through, and you'll notice this as the rocket launches. So I want you guys to pay attention to what's happening as the rocket launches, because it's actually, if you know what these points in the launch are, it can be a little bit exciting to recognize what's going on. So first, of course, we have the launch at T-0, and all the engines will be ignited, and it'll take off into the sky. And it has a really high thrust to weight ratio, so it really shoots off the pad. And I think it has one of the highest thrust to weight ratios out of like all commercial rockets, and that's because of those solid rocket boosters, which are really, really powerful. Then it's going to go through, after about 2.5 minutes, those solid boosters are going to separate from the main stage, and they're basically just going to fly away. They fall into the ocean, so don't worry about them. The core stage will continue just burning on its own for another 10 minutes, and then it's going to get to stage 3, where, so it'll be burning on its own. Then after about 10 minutes, it's going to separate from the upper stage, and that upper stage is going to take it off and kind of go away from the vehicle. And the main stage is going to come back down to Earth and crash somewhere also into the ocean. And then finally, that upper stage will be ignited, and it'll be able to carry itself all the way into the geostationary transfer orbit that it's supposed to get into. And that will basically be the end of the mission once that stage is finished burning. And again, that's going to burn for about 16 minutes, so it's quite a long one. And then, so that's basically the idea. You can also see how the orbital insertion is going to work. So basically, this is not to scale, but it is kind of roughly representing what's going on here. The geostationary transfer orbit is this white orbit that you're seeing here on screen. And that's basically going to take it from the low Earth orbit, from Earth, and it's going to take it all the way up to the red orbit that you see there. That's the geostationary orbit that we're moving these satellites into. So that's basically the idea. And that's basically how the Ariane 5 gets its payloads to where they want to go. This orbit is a lot more energy than a low Earth orbit. It takes about 4,000 meters per second more of velocity, which in percentages is about another half of the entire energy it takes to get into orbit. So it's quite a bit more taxing on the rocket to get to this place. But of course, this is exactly what the Ariane 5 has been designed to do. So she should have no problem. I'm just going to show you quickly what is special about geostationary transfer orbit. About geostationary orbit, and that's basically that the satellite is in an orbit that rotates around the Earth at the same speed that the Earth rotates, and so the effect is that the satellite kind of hovers in one spot, and that allows you to do some cool stuff with like communication satellites and these kinds of things. So that takes us into what this mission is all about. So the main mission, there's basically 2 satellites that are on board the the Ariane 5. And what's really interesting about this is that the Ariane 5 is able to take 2 satellites at once. So if we go back to the picture of the Ariane 5 here, if you go to the upper stage, you see how there's this black piece and then the satellite that's on top of that black piece. Well, what the Ariane 5 is able to do is it's able to take 2 satellites by putting one inside of that like black shield and then one on top. And they all fit into that payload fairing, and that allows them to basically have this giant volume that they take all the way to geostationary transfer orbit. And the Ariane 5 is the only vehicle that's able to do this, which is why they're able to take 2 satellites to that destination today. One of them is going to be this vehicle. It's called the MEASAT-3d, and basically it's a Malaysian communication satellite. And it's going to be doing a bunch of things to help broadcast speeds be increased in the Malaysian area, and it'll basically service the Malaysian population mostly. But I think it's also able to do some services for the general Asian and maybe Southern Europe and parts of East Africa. So that's kind of the purpose of the satellite. Most satellites that are going to geostationary orbit are doing that, so it's not uncommon for communication to be the main target audience. The second satellite that's going to be riding on the Ariane 5 is called GSAT-24. And this is also a satellite that's going to be servicing the Asian area, and it's also a telecommunication satellite. Although this one's going to be focusing more on broadcasting and TV and stuff like this. And it'll be servicing the Indian area, because it's a satellite that's been built by ISRO, which is the Indian Space Agency, basically. So yeah, these are the two satellites. Together they weigh about 8.7 tons, which again is what makes Ariane 5 unique, is that it can take so much mass all the way to geostationary transfer orbit. It's the only vehicle that can take so much mass, except for maybe the Delta IV Heavy, which is significantly more expensive. So this is what allows Ariane 5 to have the competitive edge that it has in the little niche that it has. So yeah. Let's just go into the mainstream here. We'll see where we are with the launch.
Close to the launch pad. You know it well, I imagine. Can you talk to us about it?
Yes, the beach is it's an excellent viewing point for the launches. We're a bit more than 15 kilometers from the Ariane 5 launch pad. And as the launcher flies towards the east, we have an excellent view for a few minutes up to booster separation if the weather.
So it looks like we have 24 minutes until the launch here. So we'll keep checking in to make sure that they don't have any delays or anything like that. As you know, rockets do have a tendency to get delayed in case there's any problems with weather or technical issues and things like this. But Ariane 5 is a pretty well developed rocket, so I would say the likelihood of that is somewhat lesser than it would be for other newer rockets. But we'll check back in with the mainstream as it goes here. Just to give you an idea of the history of the Ariane 5, I've created a little graph here, and this basically explains how many launches there have been per year of the Ariane 5. And so in blue here, you can see the successful launches, and in orange, we have the failures. So as you can see at the start of the rocket campaign, lots and lots of failures at the start. Nearly half of the launches ended up being failures. But then once the vehicle gets a little more mature, you see a much more successful campaign in leading up to today. And yeah, the Ariane 5 also has a very successful streak that it's been kind of going through. The streak between basically the early 2000s and 2016, they had like 60 launches without any failures. So a pretty reliable rocket. But one thing you've noticed maybe is that there's been a bit of a dip in the launches in the last 5 years or so. So why is that happening? Well, here's an overlay of the same graph, blue being the Ariane 5 launches and orange being the Falcon 9 launches. And it's quite clear where most of Ariane 5's business is going. So this is why there's been a move now in the Ariane Space to move towards the Ariane 6, which will be their next rocket that they're going to develop. And it's specifically developed to help them compete with Falcon 9 in terms of cost, because right now the Falcon 9 is just cheaper, and that's the issue. And that's why they're getting so many launches, and Ariane 5 is kind of losing market share. So I've also put a little bit of a comparison here of the Ariane 5 with the Falcon 9. You can see here that basically their payload capacities to GTO are of course quite different. Ariane 5 is able to take about twice as much as the Falcon 9. But the Falcon 9 costs much less than half of the Ariane 5. So this is why usually in a lot of cases the Falcon 9 ends up being cheaper. In the past, this wouldn't have been the case because satellites were very big that were going into geostationary orbit, usually with big antennas, big solar panels and things like this. So they were usually really, really big, these satellites that went all the way up there, sometimes weighing 4 or 5 tons, just like the ones that are being launched today. But the thing is that with the reduction of size of a lot of parts, satellites just aren't weighing that much anymore. So it doesn't really make sense to use Ariane 5 over a Falcon 9, which is a lot cheaper. So this is why the Falcon 9 has been kind of winning out in some cases, where the Ariane 5 might have in the past. But not to worry, Ariane Space is on the case. They're going to try and develop their new rocket called the Ariane 6. And here you see a cost comparison between those two rockets. Ariane 6 is going to be a little bit taller, and it's going to be a little bit slimmed down. So it's actually going to have less thrust than the Ariane 5 overall, and it's going to be able to deliver less payload than the Ariane 5 overall. But the reason for that is that, well, Ariane 5 doesn't need to have all that thrust to deliver all that payload in today's marketplace because the satellites are smaller. So it makes more sense to downsize the rocket a little bit, reduce your costs, and then they can start competing with some of the other vehicles. Unfortunately, the Ariane 6 is not going to be utilizing reusability, which is one of the main reasons why Falcon 9 is able to reduce their price point so much. So that's a bit, maybe a bit disappointing, but I guess this is Ariane Space's decision about how they see their launch operations being profitable. So perhaps in the future, we might see a reusable vehicle coming out of Ariane Space, but probably not for the next 10 years at least. Ariane 6 is the clear mission forward for that company, and we'll see how it goes. Anyways, let's just pop back in here to the mainstream and see where we are.
GSAT-24, a telecommunication satellite weighing 4,180 kilos. This passenger, owned and operated by New Space India Limited, NSIL, was built by Indian Space Research Organisation, ISRO.
So this is the GSAT satellite that they're talking about right now.
DTH services in India.
This is a communication satellite having 24 Ku band transponders, specifically designed to service the sectors which are using DTH services. We have designed this satellite based on the very proven bus of I-3K. It's a bent pipe spacecraft. We hope that with this launch of GSAT-24, this sector, which is primarily meeting the demands of the television broadcasting services in India, will really get a big boost.
Thanks to the satellite, the company will be able to offer more high-definition channels to its customers and increase the robustness of its signal in case of atmospheric rains. It is the first demand-driven satellite launched for the government of India. Once launched into geostationary orbit, the satellite capacity on board GSAT-24 will be utilized by only one client.
NSIL got mandated to undertake satellite missions on a demand-driven model. In fact, the entire satellite capacity has been leased to Indian DTH service provider, MEASAT-3d, for the entire life of the satellite, which is 15 years.
Launching this passenger is an important new step for India's space program.
With the successful launch of GSAT-24, NSIL would be owning and operating nearly 11 Indian communication satellites in orbit and meeting the service needs of the users in India on a commercial basis.
A new milestone in the long-time partnership linking Ariane Space to India. Their story began in 1981 with the launch of Apple satellite on board the third Ariane 1 ever launched. 41 years later, GSAT-24 is now all set and ready to begin its 15-year journey to space.
So GSAT-24 will be the 25th Indian satellite launched by Ariane Space. So David, it's a partnership that began a long time ago, 1981, 40 years ago.
Yes, yes.
So it's pretty crazy that Ariane Space has been launching the Indian satellites for so long. So yeah, we're looking at 16 minutes to launch here. So we're still on schedule, still no issues with the launch in terms of timing or anything. So that's good news. But we'll always keep an eye out for any issues like holds or anything. Maybe we should talk a little bit about the unique orbit that the Ariane 5 is going into today with those two satellites. So basically, let's see here. Basically, in order to get into this geostationary transfer orbit that I'm showing here, that's again the white orbit that you see. The red orbit being the final geostationary orbit they want to put the satellites into. But the white one is the one that the Ariane 5 is responsible for getting into. The key to this is that you want to kind of launch this in an equatorial orbit. So the reason for this is that the geostationary orbit is in an equatorial orbit. And if you launch in an orbit that's not equatorial, you have to make a plane change maneuver, which is really, really expensive in terms of delta V. And you don't want to do that with a rocket, otherwise you lose a lot of payload. And basically, if Ariane 5 launched from like Europe or something, it would be in a really inclined orbit of like 50 degrees or so, and then it would like not even be able to get like 2 or 3 tons into the final orbit that they want to move into. So, in order to combat this, the Ariane 5 is actually launched from French Guiana, which is right near the equator. It's at like 5 degrees, which is like really close to getting into an equatorial orbit. I think it's the most equatorial launch site in the world. And so this makes them, again, uniquely suited for getting into this geostationary transfer orbit. So just more reasons about why the Ariane 5 is kind of like really geared towards this type of launch and getting these communication satellites into these orbits. Okay, let's learn about MEASAT.
A very special passenger will be sitting on board the Ariane 5 launcher, MEASAT-3d. This satellite will be launched into geostationary orbit at 36,000 kilometers above our heads to join the rest of the MEASAT fleet. The Malaysian operator chose the European company Airbus Defence and Space to build the youngest offspring in its fleet.
The first time Airbus worked with MEASAT was for MEASAT-3b, which was launched in September 2014. I'm pleased to say the satellite is doing very well, and Airbus is very happy to be giving birth to a second bird less than 8 years after. We hope that the family will grow again in the next few years.
Using its powerful C and KU band, the payload will be able to deliver direct-to-home television in HD, 4K and even 8K throughout Asia, Australia, Africa and Southern Europe. Thanks to its powerful Ka band, the satellite will also be able to provide internet services to populations so far unserved and underserved to close the digital divide in Malaysia.
It is not just a new satellite project for MEASAT, but it's a national important project to close the digital divide in Malaysia, allowing us to expand the rural connectivity from the existing 3,000 sites to 10,000 sites, and upgrading the internet speed from 30 megabit per second today to 100 megabit per second.
With this new satellite, MEASAT will be able to bring high-speed connectivity to more people living in remote areas in Malaysia, thus helping millions of people gain access to internet.
MEASAT is proud to support the Malaysian government Jendela initiative, which is the country national digital infrastructure plan to connect the unconnected, to provide 100% internet coverage to the nation by 2025.
Yet this passenger is full of surprises. Sitting next to it in Ariane 5's fairing, a hosted payload has been integrated by Airbus for the benefits of KTSat, a South Korean operator. This L-band payload will be part of the national system called CAS, providing accurate location information within several meters.
We designed and built a very innovative hosted payload for KTSat for the Korea Augmentation Satellite System, which is called CAS, designed to significantly enhance air traffic management in South Korea. Bon voyage, MEASAT.
MEASAT-3d and its 5,734 kilograms of advanced technologies has been designed to fulfill its mission for more than 18 years.
So basically you see there just how big that satellite is. It's 5.7 tons, which is like huge for a satellite that gets launched today. Like almost none of the satellites that go up today are that big. So that's why Ariane 5 has had such a shrinking market in the last couple of years, is because, well, satellites just don't get built like that anymore. Not as frequently anyway. So yeah, this is what comes in with the Ariane 6 and why we should start seeing some Ariane 6 launches coming up in the next year. The first one is officially slated to go up in 2022, but we'll see if that happens. Rockets are always getting pushed back, right? Especially the first launch. All of us that have been waiting for SLS or Starship definitely know about this. So yeah. For those that joined just in the last couple of minutes here, we are now in T-minus 10 minutes, so we're getting pretty close to the launch. Maybe I just want to go over the staging sequence again, just so that we all know what's going to be happening in the launch coming up here. Basically, the rocket has what I call 2.5 stages, and it's going to go through a sequence that kind of looks like this. So first, we're going to see the launch of the rocket, when all the rockets are going to be lit, those two solid rockets on the side, as well as the main rocket in the middle. And those two solid rockets are basically just solid rockets running on aluminum and HTPB and ammonium perchlorate. And that center stage there is running on hydrogen and oxygen. Then after 140 seconds, so about 2.5 minutes, those two side boosters are going to separate from the vehicle, and the center stage is going to continue on going into orbit. And those two side boosters will just fall into the ocean. No recovery on them. Again, that center stage is going to continue on into orbit, and it burns for a really long time. It's going to go for about 10 minutes. So it's a bit of a long one compared to some other rockets, and that's because of the hydrogen oxygen that it's burning, which is usually it takes a lot longer to get through the propellant of that. Then finally, after 10 minutes, we're going to see the separation of the upper stage from the center stage, from the core stage. And that core stage will also join its booster brethrens in the ocean. Unfortunately, nothing is recovered on this vehicle again. So just to reiterate that. And then that upper stage will carry on into the geostationary transfer orbit that we're targeting. And that burn is going to take about 16 minutes. So also quite a long burn compared to what maybe we're used to with other rockets that are running on RP1 and liquid oxygen. And again, that's because hydrogen is hydrogen is not very dense, so it's actually a lot harder to burn the same amount of propellant and get the same thrust out of a hydrogen system than you do out of an RP1 system. But because of that lower burn rate, you also get a lot higher efficiency, and that's because, again, hydrogen is a lighter particle, so, pros and cons. And again, the orbit that we're targeting is this geostationary transfer orbit, which kind of looks like this. This is not exactly to scale, but it kind of gives you the idea of what's happening here. A lot of orbits today are going into low Earth orbit, which are just basically circles around the Earth that are really, really close, like it is on the left-hand side of that ellipse. But today we're going into a geostationary transfer orbit, which means that we have to raise the apogee of that orbit, which is the part on the right-hand side of the white orbit, all the way out to the geostationary orbit, which is the place where these satellites are going. And of course, that's the place where the rotation of that orbit is the same speed as the rotation of the Earth, which is special and allows us to be able to do lots of cool communication things where we can just point an antenna at one spot in the sky and you'll always have connection with the satellite that's sitting there. Yeah, a lot of the legacy communication satellites, like for TV and broadcasting, are all sitting up there. And that's why you can point your satellite dish at one spot in the sky and always get the channels that you want. That's basically satellite TV. So, our countdown is on hold. Okay. I wonder what's going on here.
À tous de DDO, arrêt du décompte suite à un rouge ensemble de lancement. Que tous les moyens restent prêts pour la reprise de la chronologie à I0-7 minutes en cas de retour au vert.
So 7 minutes away from the count. They've stopped the count. Not entirely clear why yet. Unfortunately, I don't speak French, so I have to kind of guess what he was saying. I would like them to remove this red thing, because then I can see what's going on in the rocket, and then maybe we can figure out what the issue is. Of course, right now they're going to be loading the cryogenic propellant onto the rocket. So that includes both the first stage, that core stage we're talking about, which is going to be getting liquid hydrogen and liquid oxygen, and of course the upper stage, which is also getting liquid hydrogen and liquid oxygen. And both of these combinations, both of those stages, are getting that at cryogenic temperatures. And it's especially critical for the hydrogen because it goes in at minus 250 Kelvin, which is like really, really cold. And it's really hard to keep things that cold. So you have to always be constantly filling that up because it's constantly boiling off as the heat of the South American jungle keeps heating up that liquid and turning it into a gas. So they have to keep venting the gas to prevent the tanks from exploding. And then you always have to top up the propellant. If they give us a little bit better of a picture, we could see if they're actually still loading propellant, but unfortunately, it looks like we're not getting a better picture than this. Oh well. So this, just to be clear, this is not, just because they're on a hold right now, that doesn't mean that the launch won't happen. They do have about a 1.5 hour window in which they can launch, which starts in 5 minutes and carries on an hour and a half after that. So they can pretty much launch at any time during that window. And the reason why they can have such a big opening for which to launch is because basically the rocket can compensate for the differences in position of the launch site with respect to the orbit they want to get into. And they can do that for about an hour and a half, and then it's too much. So hopefully we can get a reset and then still see the rocket launch today. Otherwise, I'm sure they have some backup windows in the coming days that they can target. So, but let's not get too excited yet. The solid boosters on the side of the rocket don't need to be fueled right now because they are just having they get loaded up with fuel like, you know, months in advance, and it's basically just like this plasticky binder kind of material when they mix it all together, and basically they put it in there like a mold, and once it's in the booster, then it's fueled, and they can sit like that for like years and years. Usually they use it, that kind of propellant, for missiles and stuff, for like military stuff, because you can just have it sitting in a warehouse somewhere or in a missile tube for years and years, and then whenever you need it, you can just light the rocket and boom, there it goes. So for that reason, they can be really handy. Of course, the problem comes, basically the negative of a solid rocket is that once you light it, you can't stop it. So for rocketry, it can be a little bit tricky because if you want to control the thing that you're flying, you know, solid rockets are a little bit harder to work with because it's difficult to vector the thrust and get control. Also, if you want to slow down a little bit and speed up a little bit, it's really hard to do with a solid rocket because you can't start and stop the rocket. Once you light it, it does its thing and that's it. Of course, the reason why they have them on this rocket is simply because that center stage is not able to lift itself off the ground without those solid rockets. So they really give a lot of thrust to weight, which is another advantage of a solid rocket. All right, yeah, so it looks like that basically they have some additional technical checks to make. So we'll see if they're still able to get the launch inside that launch window. But again, like I said, they have that 1.5 hours of grace here, so they might be able to get a reset going, and then we'll see where it goes from there. If you guys have any questions along the way, feel free to ask. We can chat a little bit about rocketry, or the Ariane 5, or maybe even the Ariane 6, or comparisons with other rockets, whatever you guys want. I wonder if this is a live view. It is. It must be a live view. The clouds are moving. I can't really tell what's going on the launch stand, though. They need a better resolution. Maybe we can go over the reasons for why why Ariane is deciding to switch over to the Ariane 6 in the coming future. The Ariane 5, again, like I said at the start of the stream, the Ariane 5 is basically being retired, most likely this year, although they could fly next year as well. We'll see. There's only I think there's only 1 or 2 launches that are left on the Ariane 5, so it's a vehicle that you're probably not going to see again in a couple years. And the reason for that is that the Ariane 5 is not really able to compete in the commercial rocketry market anymore, basically because it's designed for sending really big payloads into this geostationary transfer orbit I've been talking about. But satellites are getting smaller, and the amount of those big satellites that are being launched every year is getting less and less. So other vehicles like the Falcon 9, or even other vehicles that are coming online that are being built by various countries around the world are starting to eat up Ariane 5's market share. So here you can see kind of a graph of the launches per year that Ariane 5 has been having, and you can see kind of like the peak of their usability being like in the early 2000s to the mid 2010s. And during this time, of course, there weren't many options for launching payloads into this orbit. I think Ariane 5 was basically the only one that could do it. And maybe the Atlas 5 and the Delta 4 Heavy could also do it, but they're a lot more expensive. So, yeah. So here's a good question. How much does it cost to postpone a rocket launch? Yeah, so basically, rocket launches, the main cost is, of course, the rocket itself, but there are a bunch of things that are happening during the launch that can cost a lot of money on launch day. So basically, first you have to pay for the launch site and all the people that are working on it, and usually that can run up like tens of thousands to hundreds of thousands of euros in a single day. You also have to think about the propellant, like the hydrogen and oxygen that are being loaded into the center stage and the upper stage. Those cost money, of course, as well. And if you have to reset to another day, you basically have to exhaust that propellant, just let it go into the environment. So you have to pay for it. And that, depending on what you are running on, like hydrogen is quite expensive because of how cold you have to make it. Oxygen, not so expensive. In the end, it's on the order of probably like 50 to 100,000 euros. So usually to recycle from day to day, like it's going to cost you, anywhere from like 100 to 250,000 euros, depending on which launch site you're operating on, I would say. In some cases, it might cost you up to $500,000, but compared to the cost of the rocket, usually that's not such a big deal. Yeah, question, is the Ariane 5 able to carry the entire Orion vehicle into LEO? Well, yes, it can. That's the short answer. Technically, yes. If I go back to the vehicle stats here, you can see that the Ariane 5's payload capacity to LEO is 16 tons, which is enough to carry that Orion capsule, I believe. The issue is, though, that number one, Ariane 5 is not man-rated, so you would have to actually go through a whole bunch of processes in order to get the vehicle rated to fly missions that can go and launch humans. The second problem is the mission profile. So because of the fact that the Ariane 5 is running on that hydrogen and oxygen, it goes into a really long burn that goes from, the core stage and that upper stage. And this is not very good for escape possibilities. So basically, you want to get to orbit really fast to enable you to have a safe escape system. So the Orion capsule has this nose on it with solid rockets, which will light and take it away from the rocket if there's a problem. Basically, the G-forces that the crew have to go through on the way back down, though, are affected by the trajectory that the rocket's on. And the trajectory that Ariane 5 takes its would-be humans on, would not be a good one for that. So although it's technically possible to launch an Orion capsule on an Ariane 5, you'll never see it happen for those reasons. And the Ariane 6, I think, doesn't have the payload capacity to launch an Orion. So unfortunately, Ariane vehicles are not really designed for that. That is more for the Atlas V. That's kind of in its wheelhouse. Yes, rocket launches are very expensive. That is always a problem. If you go to the cost stats that I prepared down here, you can kind of see the comparison. So like an Ariane 5 today costs around 150 million. Although it depends on it depends on a mission per mission basis. It can go up to like 180 million. So yeah, getting these types of launches is of course really expensive. But you know what's even more expensive than launches is launch failures. So we like to make sure that there's going to be a really good chance of success. Otherwise, you can get into situations where it can get a bit dangerous. And then you could lose that 150 million investment. That's not good. Are there similarities between the Ariane and ASTRA rockets? I'm assuming that you mean the ASTRA rocket company that is in America. They are very dissimilar, I would say. So basically, the Ariane 5 is specifically designed to get really, really big payloads into orbits that are really, really far away. Whereas ASTRA's rocket, the Rocket 3, is designed to get really small payloads into orbits that are really close to Earth. So in a way, they're kind of like not competing with each other at all. They go to the exact opposite places. The payload capacity of the Ariane 5 to low Earth orbit is like 16 tons, whereas ASTRA's Rocket 3 payload capacity is like 150 kilograms. So quite a large difference. In fact, you could probably almost put an entire Rocket 3 into the payload bay. Well, it wouldn't fit volumetrically, but if you could fit the mass in there, you could almost fit the entire thing and just launch it on an Ariane 5. So it's, definitely vastly different scales of rocketry. If you are meeting ASTRA, the student group that I'm a part of in Bremen, then our rockets are again very different. The Transcendence vehicle that we're building is just going to go to an altitude of 100 kilometers and come back down. So it doesn't actually go into orbit. It just goes into space and comes back. This is usually the kind of trajectories that amateur rocketry people go on. Building an orbital class rocket for an amateur is quite difficult. So mainly because of money. Building an orbital class rocket costs like, tens, if not hundreds of millions of dollars. So, yeah. Anyways, Jesse, keep up the learning. There's lots of new rocket companies that are coming up. So, there's just in America, there's of course the two big ones, SpaceX and United Launch Alliance. And they built the big rockets. Those ones are kind of similar to the Ariane 5 in terms of volume and scale and payload capacity. But there's lots of little ones that are coming up, and that's like the Astra or Firefly Aerospace or Electron. or Virgin Orbit, all of these other ones. Those are the ones that are doing really, really small payloads that are only like a couple hundred kilograms. So I kind of grouped the rockets into that kind of general classification. Rockets like the Ariane 5 are basically heavy lift rockets that do really, really big payloads. Oh, we have a change here. Let's see. We're still at 7 minutes, so we're still stuck there. Okay, maybe not a change at all. Hopefully they update us with what's going on. Ariane Space is not quite as good with the whole community interaction as some of the other launch vehicles are. Of course, SpaceX gives you like live updates constantly as things are happening. Ariane 5 is like the exact opposite. They don't really worry about the community so much. Yeah. It would be interesting if Ariane Space decided to actually build a rocket that's more geared towards payloads that go to low Earth orbit, but that doesn't seem to be something that is on the horizon. Okay, 3 questions. Okay, here we go. Do we know why Rocket 3 Tropics 1 failed? Answer is no. ASTRA has not released anything officially or publicly about why it failed. What we do know is that the engine shut down about a minute before it was supposed to. So that means that they didn't get enough speed to get into the orbit. So essentially the rocket just came back down and crashed in the ocean. So yeah, that's unfortunate. Why the engine shut down, we don't know. It's actually a little bit weird for a second stage engine like that to shut down because it's a pressure fed engine. So it's like no moving parts. You just, flip a switch and the valves open and the rocket should go. So the rocket shutting down is a bit odd. Nothing exploded based on what we see in the footage. So it doesn't look like the engine bell failed or anything, or the combustion chamber exploded or something like that. And the spin that the rocket went into when the engine shut off was not very severe. So it doesn't seem like something like flew off it or anything. So it seems like it was something internal to the code or internal to the operation of the sensors. Maybe it saw something like a pressure peak or a temperature spike, and that's why the engine shut down. It could be something like that. But until they tell us officially, of course, we can't know. Was there ever a failure of the Atlas V? Technically not. Not as it was called the Atlas V and operated by United Launch Alliance. So United Launch Alliance officially formed in like 2005 or something, and their vehicle, the Atlas, was then their main vehicle, and in that configuration, the Atlas V has not failed. However, Atlas as a program has had many failures before that. So when United Launch Alliance markets their Atlas V like, oh, we've never had a failure, that's a little bit misleading because it was already a fully developed vehicle in 2005. So, yeah. Ariane 5 was designed for Hermes, so is it possible to fit crew? It's possible. Of course, technically it's possible to fit crew. But the problem is it's not, the Ariane 5 is not human rated. So it needs to get human rated first, and then it would be able to take crew. And there are a couple things that would have to change in order to be properly human rated, in my opinion. Although maybe I might be wrong about that. So the key there is thrust to rate ratio of the main and upper stages. They're just not high enough to get into safe trajectories so that escape is possible for the entire trajectory of the insertion into orbit. You want escape possibilities because in the case the rocket blows up, you have to be able to get back to Earth and keep your people alive. That's usually really important. Yeah, the ether engine could have been shut down on Rocket 3 if the engine lost pressure. But again, for a pressure-fed engine, it's really weird that it would lose pressure because it's just you open the valves and the pressure inside of the tanks themselves are what are providing the rocket with pressure. So unless there's a failure of the tank, you wouldn't expect to ever lose pressure. And if the tank failed, I feel like we would have noticed that in the live stream. There would be like parts of tank flying all over the place, and you'd be in some crazy spin because an explosion of like a failure of the tank would create a lot of like, you know, asymmetrical thrust that would push you into some crazy spin. But we never saw that, so I feel like it's not something like that. The loss of pressure would most likely be caused because the valves are closed, and that's something that would happen because of software. So that's why I'm leaning towards this being a software thing. But we'll see. We'll see. Once they'll update us, I'm sure, in the next couple of weeks here with what the problem was. And I'm sure they're going to try to get back to flight again. The last time they had a failure, they were back on the launch pad like a month later. So maybe they'll be back on the launch pad just as quickly this time. But we'll see. Yep. So we're still at 7 minutes with this launch. Again, I just want to reiterate that this is an open launch window. So the T-0 time was initially set for 9:03 UTC, which was about 15 minutes ago. But we do have a 1.5 hour launch window today. So they do have an ability to reset and launch the rocket again. They may add more time to the clock once they decide to do that, but right now it's being held at 7 minutes. Yeah. It's not really good to speculate about why rockets fail with just the footage that you see in the live stream, because there's like so much more data that is being collected by the rocket makers. Like they have so many sensors on that upper stage and different views that, of course, we can't see. So it's all a bit futile until you get the official report, I guess. Although I think it would be a really cool job to have, to be looking at that data after the failure. That's always, yeah, failure analysis is always an interesting thing to do. The time, yes. Once again, we are in a hold. So the initial launch was planned for 9:03 UTC, which was 15 minutes ago. And we do have an 1.5-hour launch window. So we have an hour and 15 minutes left for which we could launch the Ariane 5. We don't have any information from Ariane Space, though, about whether they want to recycle or what's happening. All we have is this text we see there in the red. So yeah, we'll see. And unfortunately, I can't get my little clues about what's going on because of the vehicle being covered by the red text. Like, do we see any like launch gas clouds or anything coming off the rockets? It's tough to tell. If they're still fueling the rocket, you should see like, you know, vapor clouds coming off the tanks and stuff, because the liquid oxygen and the liquid hydrogen are always boiling off as they when they're in the tank, and that usually can indicate to you that they're still trying to launch. But because we don't really have that view with the camera, unfortunately, it's tough to tell those little details. Unfortunately, Ariane Space is not quite as good at updating the community about what's going on with their rocket. Yeah. They also don't do much in the way of explaining how the rocket works. They just kind of do the live stream, you watch it, and that's it. That's why I think it's good that, you know, some people are here that can kind of answer some questions about how the vehicle works and stuff. Yeah, if you guys have questions, keep them coming. I am an aerospace engineer, so I know some things about rockets and how they work and stuff. Maybe we should just go into, for people that have joined in the last little couple of minutes or so, we can go over the mission profile one more time. So the Ariane 5 is a very specific type of vehicle which has 2.5 stages, as I call it. And basically it's going to, if it launches today, it'll go through these sequence of events. So basically we'll have the ignition of the rocket, which includes those 2 side boosters and the core stage. Then after 2.5 minutes, we're going to see the separation of the side boosters from the vehicle. And the main stage will continue to operate. The side boosters will fall back into the ocean, and then they will not be recovered. So unfortunately, it's not a recoverable vehicle. The core stage continues on into orbit. It burns for about 10 minutes, and that's because of the hydrogen-oxygen system that it's using. So it takes a little bit longer to burn those types of propellants. Then after 10 minutes, we're going to see the separation of the core booster from the upper stage. That core booster will, of course, also fall into the ocean because it's not being recovered. And then that second stage will carry on into the geostationary transfer orbit that we're trying to get into today. And no, you did not miss anything. Right now we are in a hold, so the rocket is just standing by on the launch pad. We don't have any information from Ariane Space about the progress of that hold or whether they will try to continue launching. What we do know is that we have a 1.5 hour launch window to launch the Ariane 5. So we could launch anywhere from now up until about 1 hour and 10 minutes from now. So we're just waiting on Ariane Space to see if they're still going to recycle and try again today. The clock is still steady and holding at 7 minutes. So the orbit that we're going into, as I've been discussing today, is basically we're going into this geostationary orbit. Those are where the satellites want to go. And the reason why they want to go there is because it rotates, the orbit rotates at the same rate that the Earth rotates. So your satellite kind of is fixed in the sky. And that makes it really good for communication satellites. And the Ariane 5 has 2 communication satellites on it today. One of them is this MEASAT satellite, which is a Malaysian satellite. It's planned to go into a geostationary orbit where it's going to be doing a bunch of communications type operation. It's going to deliver basically high-speed broadband to Malaysian people, basically direct from satellite to house type of thing, kind of like Starlink. Although it won't quite operate the same as Starlink, so it's a little bit different. Because of the large distance that it has to go through, you still get kind of long lag times, unfortunately. It's also being used for other telecommunication things, but mainly servicing the Malaysian market. Then we have an Indian satellite called GSAT-24, and that is also going into a geostationary orbit, and it's going to be servicing the Indian area. It is also a telecommunications satellite, and it's going to be basically doing mostly broadcasting and TV and stuff for, again, the Indian market. I think it got bought exclusively by one broadcaster, so it's like literally like their satellite, no one else's. Yeah, surprised that they have the funding to just be able to buy a satellite like that, because they're not cheap. These things are like hundreds of millions of euros, so quite impressive. So we're still holding at 7 minutes, unfortunately. Yeah. I don't know. I think that we might get an update soon. If we don't get an update in the next probably 20 or 30 minutes, then they're probably just gonna recycle and try again tomorrow or something. Yeah. In the meantime, maybe we can talk a bit about ASTRA's, the ASTRA I'm a part of, the student group, what we're up to. So of course I'm Josiah. I'm the chief engineer at a little rocketry student rocketry group called ASTRA, and we are trying to build a rocket that goes to space. So it's going to fly up and go to the Kármán line and come back. It doesn't go into an orbit like the Ariane 5, but it does briefly go into space, kind of like the New Shepard or the Virgin Galactic vehicles. Ours doesn't take people, it just takes some payload. But yeah. So over the next 2 years, we're basically going to be designing and trying to build and test this rocket. We've made some pretty good progress over the last couple of months. We've been testing our recovery system a lot, and we basically built this whole like setup where we have a frame that kind of looks like a guillotine, and we're using that in order to drop a weight that's supposed to simulate what opening the parachute is going to be like on the recovery package. So we can basically simulate the shock forces that the recovery bay will experience by using this setup. And we have a whole video about our first round of testing. You can, if you go to the channel, you can find the video on that. It's yeah, it wasn't quite as successful as we were hoping. We had some key failures of the system. Some of them failed in somewhat spectacular ways, so maybe interesting to check out. We have a second round of testing that we just performed, which was a lot more successful, so we were able to fix some of those problems, and we'll have a video on that coming out pretty soon, probably. We still have a couple things to fix up there, though. We've also started with designing our propulsion system. We're going to be using a hybrid rocket to do this, so it's not a solid, it's not a liquid like the rockets that Ariane 5 has on it. It's actually what's called a hybrid. So we have a liquid oxidizer and a solid fuel. The solid fuel is paraffin wax, and the liquid oxidizer is nitrous oxide. And right now we're focusing on making that fuel grain, the fuel part, so the paraffin wax. And we are designing basically a frame which we will use to basically form our paraffin wax grain. And it's basically just this wooden frame that has a motor on it and has a tube and some bearings, and we can fill that tube with paraffin wax, and then we'll spin it, and then as the paraffin wax cools, it will harden, and you'll get basically a cylinder of paraffin wax with a core in the middle, which is where the nitrous oxide will flow through and burn to make the combustion reaction happen. So yeah, we've been in the lab working on this frame for that, and hopefully we'll be able to start making some paraffin wax grains in a couple of weeks. So yeah, we'll update on our channel about the progress on that also. Finally, we've also started to do some carbon fiber wrapping. So basically, in order to allow our rocket to be able to get to the Kármán line, it needs to have a really good structural mass. So the less mass we have, the further the rocket will go. So we need to get a really good material that gives us high strength but also low mass. And basically we've selected carbon fiber to be able to do this. But you can't just melt down carbon fiber and extrude it into the shape you want like you can do with like metals and stuff. You have to wrap that carbon fiber, kind of like a fabric, right? So we've started using basically a wrapping machine to start making those tubes that we're going to use to make the structure of our rocket. And we do have a pressure test, which is coming up in about 2 months, where we're going to test basically our plan of how we're going to make the tanks and the combustion chamber with this carbon fiber. So also be some excitement there, although hopefully no explosions. So yeah, lots of stuff happening there in our group right now. Yeah, stay tuned on the channel to get more updates on that. And also, if you're curious, you can also buy some of our merchandise. We have like sweaters and shirts and stuff, like the one I'm wearing right now. I always wear them in the videos, so if you like what's being worn, you can head over to our website or to our merch shop, which are in the description below. And yeah, if you see something you like, go ahead and buy it. All the profits from that go to our group. So basically, it helps us get a rocket to the Kármán line, and you can be part of the mission. So that's pretty much where ASTRA is right now in terms of development. The last thing that maybe I could talk about is we do want to launch a rocket sometime at the end of this year, maybe beginning of next year. And that's going to be one that's just going to be a demonstrator. So it's not going to go fully to the Kármán line. It's just going to go a couple kilometers. But it will demonstrate the technology that we want in order to develop the rocket that goes all the way to the Kármán line. It's difficult to convince a launch site of your reliability without having launched a rocket before that. So that's kind of the reason why we're doing that. So we're still in a hold with Ariane 5, unfortunately. It's unclear as to whether they will update us about what happens next on the rocket. Maybe I should check their Twitter. Let's see what they're saying. I don't see any updates on their channel here about it. They just have the So 5 minutes ago they just said that they have a restart of the upper stage fueling operations. So it looks like we might continue. Okay, so they've restarted the fueling. So this is a good sign. We might get a new T0 soon if they've started the refueling. But that was 5 minutes ago, and we still don't have any updates on the stream. So we'll see. Twitter says we're back to refueling. Although I'm not entirely sure how long it takes to fuel an Ariane 5. Loading hydrogen is always difficult, so sometimes it takes longer than you want it to take. Meat sack launch, yeah. I don't know if there's any meat eaters in geostationary orbit, but no, it's MEASAT. MEASAT, not meat sack. Yeah. Of course, the space industry loves their acronyms, so you always have these like acronyms for these satellites and stuff. They should give them better names because, you know, who's gonna remember MEASAT? Like, yeah. But that's just a result of space engineers being relatively uncreative, unfortunately. We kind of just call it what it is. So maybe they'll give another update on Twitter. But right now, they've said that they're restarting the upper stage fueling. So depending on how long upper stage refueling takes, we will see what comes out of that.
À tous de DDO, suite au retour au vert des moyens lanceurs, le nouvel A0 visé est 21h50 00 TU. Le temps décompte démarrera à 21h43 00 TU.
All right, so we had something. Does anyone speak French on the stream? Unfortunately, I do not speak French. Despite being Canadian, I don't speak French. I come from the western part of Canada, so we don't usually speak a lot of French out there. Although I feel like they're going to restart the clock soon. Everything's green now on the board. Before there was a red piece that was indicating that they were not ready to go, but everything's green now. So yeah, as I was mentioning before, the fueling process. So because the upper stage is running on hydrogen, hydrogen takes a little longer to load in general, just because it's a much less dense propellant. So comparing it to, let's say, RP1 or, oh, here we go, 950. So that's in 12 minutes. 12 minutes is the new T minus 0. This is good news. So yeah, the loading process for hydrogen is a little bit longer because of how not so dense the hydrogen is. Basically, in comparison, the density of hydrogen is literally like 1/20th or 1/15th of other fuels that you can use. So it takes, like, if you're running a pump to pump the hydrogen into the tank, it takes a lot longer, just because to pump the same mass of propellant, you need like way more time, just because of how much volume you have to move. So it makes the fueling operations a bit more complicated, I guess. You also have to keep in mind that hydrogen is going into the propellant tanks at minus 250 degrees Celsius. So like colder than you can, than any temperature you've experienced for sure. And getting the hydrogen that cold is quite the challenge, and keeping it that cold is even more challenging. So there's lots of insulation that's built into these, into the Ariane 5 to keep the hydrogen cold for as long as possible. All right. Now that we have a recycle time, I would hope they would switch to the view of the rocket and stop covering it with this red thing. Basically, we should start to see some fueling clouds coming off the rocket, indicating that they're fueling. But yeah, that would require them to switch to more of a rocket view. We'll see. What's the countdown? So we have the T0.
Hello, welcome back on Road to Space. We just interrupted the launch and the program. Just at the time, David, we were talking about this green panel, and we were talking about those green lights, and just at this time, one turned into red. What happened?
Yes, that's right. So during the checks that were done at the end of the filling of the tanks, there were some measures that were seen that were a bit out of the usual measures that we see in this case. And therefore, of course, we take no risks, so we stopped the countdown and we analyzed these measures to make sure that there was nothing that could stop the launch. And therefore, now the teams have finished the analysis. Everything is just come back to normal, so we can launch again the.
And as you tell us before.
So yeah, just to reiterate, the count is now at T-minus 8 minutes, according to the time that they gave us. We're not actually holding at 7 minutes. I don't know why their clock is not starting to move yet, but we'll see. Yeah, so the launch is coming in 8 minutes, but we'll see if they can show us an actual countdown clock eventually here.
Rocket Ariane 6 and learn more about the community of Ariane cities.
Nous sommes fiers du soutien et du parrainage de Bordeaux Métropole.
We will unveil the secrets of one of the space industry's most unknown jobs. And finally, we'll be answering all your questions on social media. So don't go away. Stay with us and enjoy the ride.
So David, we're only a few minutes from liftoff. So what is happening right now to the two passengers at this time?
Finale lanceur. Le nouvel A0 est 21h50.
Here we go. The countdown has started.
Yes, so we just
7 minutes left.
DDO we've just been hearing.
Right, we just heard the DDO announce the start of a synchronized sequence.
Yeah.
And the new liftoff time, which will be in 6 minutes and 40 seconds. So yes, in this last minutes, we will have the final pressurization of the tanks, of the liquid hydrogen and liquid oxygen tanks. We will start in a few seconds, a few minutes, the opening of the valves that would feed the main engine with propellants. And shortly before liftoff, we will have a handover from the ground equipment to the launcher, who will control the power and all the last steps before liftoff.
At this time, is it still possible that Ariane 5 doesn't lift off?
Yes, again, in these last minutes, there's a lot of tests that are going on. And so, of course, we have done some controls before to make sure that everything goes as expected. But there are some tests, so these tests could always stop the launch.
Okay, so it's a stressful time since teams have been working for weeks and months. And so we have some images of that campaign that we'll be watching. And if you're okay, David, you will comment all those images for us.
So yeah, basically we're only a couple minutes away from launch now, and we're going to hopefully see a rocket take off. It looks like they had some problems with the pressurization of the fuel, so the hydrogen in the upper stage. Basically, they saw some values that were out of range, that were not looking like the ones they wanted. So they ran some tests, recycled the rockets, and now it looks like we're actually all ready to go here. So hopefully we'll get to see a launch of this MEASAT and GSAT-24 pretty soon here. And here you can see how big these satellites really are. Like, look at the comparison between the satellite and the size of the people. Like, these are massive, massive satellites. And this is what Ariane Space is basically specialized in. This is what the Ariane 5 was built for, was taking these big, huge satellites into this geostationary transfer orbit. Yeah, rockets like the Falcon 9 literally just couldn't do this. Those satellites are too big. They have too big of a diameter. They're too massive for for both of them to be able to go the way the Ariane 5 takes it. And yeah, really, truly impressive to see this rocket take those big, massive things into the orbits that it's going into. Like, it's really truly a huge technical feat. Of course, there's not so many of these big satellites that are being built anymore, because satellites are getting smaller and smaller, as more technology comes and you're able to miniaturize more components and more systems. So Ariane 5 is kind of like a dying breed. You don't see these types of vehicles designed this way anymore. And so this is why Ariane 5 is, of course, switching to the Ariane 6, and we're going to be having that rocket coming online pretty soon.
It looks like everyone has done an incredible job to make this all happen. If you look up on your screen now, you will have some live images from the Guyana Space Center in Kourou, and inside you have the Ariane 5 launcher. Inside the Ariane 5 launcher, you have two very special telecommunication satellites, MEASAT-3d and GSAT-24, who are both waiting patiently for the green light to lift off. We are now exactly 2 minutes and 50 seconds from the liftoff. What are the next steps before the launch?
Yes, so right now, as I mentioned before, the final tests are being done. All the valves are starting to be open and to be checked. And yes, in a few minutes, the control of the operations will be handed over to the launcher.
Usually the control of the operations go over to the rocket in the last minute with 60 seconds left. And that's just basically the rocket is able to control the entire sequence from there. So it can decide if there's a problem and just stop the launch. And usually that's, because of like pressures and stuff like that, or issues with the engine or something. So if there's a technical problem, then that's usually when it'll stop. But hopefully they're going to go over to the rocket here pretty soon.
that are following the last operations. And by the way, I take the opportunity to say hi to them, even if I know that at this time they are fully focused on what they're doing.
I don't know if we have the possibility to watch at the Jupiter room, because we see all the people in the Jupiter room moving to the windows. Well, those are the people.
Attention pour moins 1 minute.
1 minute left,
we
guys.
Has an image of people watching.
Yes.
Because people are attending over there.
I0 moins 1 minute.
Yes.
1 minute from the liftoff.
That's right.
DDO has just announced the countdown. Let's immediately go to the green panel on our screen.
You'll
Make sure
notice
all is
their
good,
operational readiness room is much bigger than Astra's.
Everything continues to be green, so we're still go for launch.
And now we are 42 seconds from the ignition. So this is the moment we've been all waiting for.
Here we go.
Let's cross
Close-up
fingers
view of the
and
rocket.
Let's enjoy the show, because it's always incredible.
Yes.
I think fueling is complete now. I don't think they're doing any venting at this point. So you're going to see this rocket take off really fast off the pad. It's got a really high thrust to weight ratio. So get ready.
Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3,
So that's the fueling lines going.
Top.
And here comes the rocket ignition. And then they're going to light those solids.
Allumage Vulcain.
There we go.
Allumage 2EAP, décollage.
You see how fast that thing goes off the pad? Incredible.
Propulsion nominale, tous les paramètres à bord sont normaux.
So those solid rockets are going to burn for about 2.5 minutes, and then we're going to see those separate.
Well, we have just seen Ariane 5 disappear into space. Do stay with us, everyone, because what's going to happen next is as crucial as the launch.
Trajectoire nominale.
This is, of course, the moment when the two satellites, GSAT-24 and MEASAT-3d, are placed into orbit. David, you're our space expert tonight. Ariane 5
Okay,
still
we
has
can
a
kind
long
of see
way to travel
the
before
live
separation of the two
broadcast of
satellites.
the
Where
of the
and
rocket
when
there
will
in
this happen? How many
the
kilometers
in the
away from
upper
launch site?
mid right-hand
Yes,
corner
we're
there.
not quite there yet, yes. MEASAT-3d, we will separate.
It would be nice if they would switch to that view. I don't know why they love to have the animation. Yeah, so basically safety checks were involved in that tanking process. Basically, they're always monitoring the pressures of the tank and the flows going into the tank and things like this. So that's basically what was going on there. So everything's going nominal.
From the launcher through the tracking stations, and they are checking that everything is going according to what was foreseen.
So we should see those solid boosters coming off in just under 20 seconds here.
So it was really impressive. And it's really nice night.
Yes, it's clear skies.
Just before the satellites find their fun. I'm interrupted because we have DDO. Everything is okay. Yes. Before the satellites find their position in orbit,
it looks like we just
6,000 kilometers above our head. David, what should we be focusing on?
So right now, yes, we just had the separation of the.
There goes the separation. You can see the two of them coming off. Look at that! Wow.
That's the first time we see it so clearly. That's incredible.
That is amazing.
So the launcher is at an altitude of about 70 kilometers and traveling about 7,000 kilometers per hour right now.
We will also, we've just heard the DDO has announced the fairing separation.
Yes. So
why we don't need it anymore?
No, the launcher has now reached an altitude around 110 kilometers.
So you can see there those two boosters, like you can see just so clearly because it's a clear night. You can like literally see the flame on the boosters as they're coming off. Oh, stop! They keep switching to the talking. We want to see the rockets.
Shortly, yes.
It happen shortly, and you have
an earpiece.
An earpiece, and so you're directly connected.
Okay, we get the animation of the separation of the payload fairings. So, all right.
Us on road to space, the Ariane 5 rocket has just left the Guyana Space Center in Kourou 3 minutes ago, and tonight we have two very special passengers on board. One from MEASAT, Malaysia's first satellite operator.
Well, you're lucky to have missed the hour-long wait we had waiting for the hold. So. So this core stage is going to burn for, like I said before, about 10 minutes, which is going to be another 6 minutes. And I think we're only going to get the animation today. They do not have a camera on board this rocket, unfortunately. So yeah, we got the tracking shot from the ground, and that was pretty nice to have. And we got to see a really good separation of those boosters. I've never seen them separate with such clarity before, so that was definitely cool.
Okay, MEASAT-3d is part of the MEASAT family. We had MEASAT 1, 2, and 3A, launched all by Ariane Space in
Looks like everything's nominal, so that's good.
2014. It's a long-time partnership between the client and Ariane Space.
Yes, indeed. Ariane Space has had a very strong relationship with the Asia-Pacific region for decades. And MEASAT and Malaysia are indeed very important customers to us, yes.
MEASAT-3d and GSAT-24 are still continuing their journey into space on board Ariane 5. Let's now have a look at the screen and some incredible images we have of today's liftoff.
We do still have the altitude and velocity readouts. So you can see here basically how fast the vehicle is moving.
I'm going to ask you, David, probably to comment on them.
Yeah. So we can see on the
and
screen what we have.
Basically, in order to get into orbit, so low Earth orbit, they'll need to get up to about 7,800 meters per second.
Yeah,
but of course, they're going to be going to a geostationary transfer orbit, which requires you to get up to a velocity of about 10 kilometers a second or so. 10.5, somewhere in there. So we're not quite there yet. We're only at about 3.7 kilometers a second. But this core stage is going to get all the way nearly to orbit by the time it finishes its burn at about 10 minutes. So You can also see the altitude here, which is already up over 100 kilometers, so the rocket is in space. And you can see that velocity ticker climbing. But the altitude doesn't change that much as we go up. You may have noticed that. Basically, because of how low of a thrust the Ariane 5 has, I don't know if any of you guys have played Kerbal Space Program, but whenever you have a rocket that doesn't quite have the thrust that it needs to get into orbit, you kind of end up having to do this thing where you are, thrusting not parallel with the Earth as you fly, but instead you're kind of in this inclined thing where you're still trying to fight gravity a little bit. Well, that's exactly what the Ariane 5 is doing right now. It's kind of in that inclined position, and that's just because of how low of a thrust its engine actually has. So kind of an interesting factoid about how it performs its orbital insertion. And that's purely a result of the low thrust to rate ratio that it has. Rockets like the Falcon 9 or other rockets that are using like LOX and RP-1 usually have the thrust to rate ratio they need in order to push themselves into going straight along the trajectory of their launch. So we have 2 more minutes left in the launch. Not in the launch, sorry, in the core stage burning. And then we should see the separation of the vehicle. We'll at least see it in the animation. We'll take Ariane's word for it that it's happening in real life. We still have the altitude and distance and velocity readouts. Those are coming live from the vehicle, so we do have an idea of where the rocket is based on that. And we also have that chart on the left-hand side of the screen. Oh, we just had separation of the core booster. And then we have the ignition of the upper stage there. And you'll notice that the velocity readout is now increasing much slower than it was before. And that's because, of course, the engine on the second stage is even weaker than the one on the first stage. And this one's going to burn for a really long time. It's going to burn for like 15 minutes. So don't hold your breath. So the rocket is nearly in orbit now. And its altitude is actually falling. Don't worry, that's not a bad thing. It's doing that because of the, again, like I said, the low thrust to weight ratio. So because of how low that thrust to weight ratio is, it basically needs to perform that burn at an incline. So it's not perfectly parallel to the Earth, it's a little bit inclined. So it's fighting gravity a little bit until it gets above that 7,800 kilometers per second, 7.8 kilometers a second that it needs to be in orbit. And then it's going to continue all the way up into that geostationary transfer orbit that we talked about earlier in the stream.
It's an incredible. So let's watch this.
So it looks like they're going to replay the launch here. Let's see. Maybe they're going to show the whole thing this time on the big screen.
Here we go.
Well,
Here we go. Ah, that's the shot we want to see.
Main engine ignition just before the boosters are ignited and then the launcher lifts off. It's indeed a very impressive sight.
Yeah, it really takes off the pad really quickly.
1,500 tons of thrust, and in a few seconds the launcher reaches the speed of sound. So yes, it's always a very
Tous les
powerful
paramètres à
site.
bord sont normaux. Propulsion nominale.
Okay, so in roughly 15 minutes,
The
our
tracking
first
cameras aren't
satellite,
always the
MEASAT-3d,
greatest
will separate
with the Ariane 5. They're always struggling to find the vehicle. It's not their fault though. It has a really high thrust to weight ratio. But wow, you can really, this is actually a really nice view. I want to see that separation again. It was really a nice one. And if they have this, this tracking camera on that separation, it's really going to be interesting to look at. But you can see the flame that the Ariane 5 makes is mostly basically those solid rockets that are generating those colors in that flame. And that is mainly because of the aluminum that's in the rocket fuel in the solid rocket boosters. So because of that aluminum, it basically glows hot when it gets hot inside of the combustion chamber and comes out the nozzle. And that's what's causing the bright color of the exhaust that we see. The exhaust of the core stage, the Vulcan engine, is actually almost see-through. So you don't really see it as well. Which is why when these solid rockets turn off, it's always going to look like there's no rocket going at all. And that's just because of the fuel types that are used. They're not going to show the separation? My goodness. And they're not showing the velocity and altitude numbers anymore either.
Okay, we just heard true télémesure.
Ah, here we go. They're back.
We are expecting.
They're just flying over the Atlantic Ocean in a place where they didn't have coverage.
So those little seconds.
There were few seconds.
Few
yes.
seconds.
It was really very short. Yes.
David, I'd just like to bring up something that caught my eye, which we haven't talked about for the moment. The logo of the city of Bordeaux, which appears on the rocket's fairing. What can you tell us about this?
So we're almost at orbital velocity now. And if you can, basically, once we get to the 7.8 kilometers a second, we'll be there. You can see on the left-hand graph there, which is plotting basically the altitude versus the downrange distance. We're going to be coming to the lowest altitude in just a couple of seconds here. And that's basically the point where we're going to be officially in orbit, and then the rocket should be going on an upward trajectory from there. So it'll get down to about 150 kilometers in altitude or so, and then it's going to start ascending up to the geostationary transfer orbit that we want to get into. And it keeps telling us that things are nominal, so that's good.
Worldwide, not only for its relaxed lifestyle, its gastronomy, and its great wines, but also for the historical role it's played in the aeronautics and space industry. 7 of the largest groups in the sector have been based here for years.
So I guess
Among
Bordeaux
them,
is somehow
Ariane
a part
Group.
of this launch.
In Bordeaux Métropole, Ariane Group is present on 3
It's
sites.
unclear how,
in Le
but
Haillon,
okay.
Saint-Médard-Issac et Saint-Médard-Centre.
Ariane nous fait rêver. L'espace est un rêve. Mais l'espace, ce n'est pas qu'un rêve, c'est aussi une industrie. Et évidemment, Ariane Group y trouve toute sa place. 3000 salariés quand même ici, dans un ensemble de l'aéroparc de presque 50 000. Donc c'est une industrie très puissante, une des plus puissantes du pays.
It is also the leading employer in the aeronautics and aerospace sector in the Nouvelle-Aquitaine region.
L'ancrage territorial d'Ariane Group est un atout. Notre société accorde une attention
I feel like it should be a crime to cut to something else in the middle of the rocket launching. Like, what could be more exciting than watching the rocket launch? But hey,
the development of the strategic area
I guess this is
and
the
makes
style
it
of
more
Ariane Group.
attractive. An area of 3,400 hectares where some 300 companies in the sector are located, creating more than 20,000 jobs, which translates into 42% of the jobs in the aeropark. Thanks to technological innovations,
So just to go over where we are in launch right now, basically we are currently at stage 5, which is the turning on of the upper stage and flying up into orbit. This is going to be again, like I said, it's a usually a 15-minute burn or so. So that started about 6 minutes ago. So we got about 9 more minutes of this or so. And then that engine will turn off and we'll be in that geostationary transfer orbit. And we need to get to a velocity of just over 10 kilometers a second. And then we will be in that orbit that we want to be in. And then there'll be a delay of some minutes, I think like 20 minutes or so. And then they're going to basically release those payloads into space. And they're basically just going to float up. So they'll be released somewhere in the lower part of this ellipse here. And then they're basically just going to float up all the way up to the top of this geostationary transfer orbit. That's going to take basically half a day. Or no, it's going to take a bit faster than that. Maybe like 6 hours or so. And then the satellites on board, they have their own rockets and their own thrusters, which will get them into the orbit they want to go into. So that's the plan for the day. We'll see if hopefully they switch back to the launch eventually here. That's kind of what we want to see, right? So this is the Ariane 6, and this is the 4 booster stage version of it. And this will give them a bit more thrust.
Politicals, researchers, entrepreneurs, and investors.
So here we can see the altitude and the velocity again on the screen, which we like to see. And we're getting there. We're at 8.3 kilometers a second or so. And you can also see on the left-hand side the graph that's showing the altitude versus downrange distance. And you can see that we have passed the point where we're in orbit, and we're now starting to ascend into that geostationary transfer orbit. So this is good news. That means everything's working. We don't have any problems on the rocket, and we're getting to where we want to go. And that rocket will continue to ascend throughout the next 7 or 8 minutes of the burn until it turns off that engine, hopefully going at the speed we need to go, which is just over 10 kilometers a second.
The upper stage performs maneuvers at the end of its mission to reduce the perigee and the apogee, and this helps to reduce the time it remains in orbit.
So they're talking about how they
we'll
deorbit the vehicle.
Ariane 6. Just the word, how the new launcher is more sustainable.
Yeah, so the upper stage of Ariane 6
referring to the Ariane 6, of course.
Capability that will allow it to clear the operational orbits. So most of the time by deorbiting it, or by transferring it to a safe graveyard orbit.
Okay. The European Space Agency recently named a startup, ClearSpace, in charge of the world's very first mission to demonstrate how to remove large space debris starting in the 2025. Do you think that they will?
So it's always important to be a good steward of space. And of course, the rocket is designed to remove itself from orbit once it goes up there. And it does this by basically performing a death burn, I guess. So when it gets to the top of that trajectory, so when the rocket will, of course, be drifting up to geostationary transfer orbit as well. So once it gets up to the very top of that orbit, you see where it meets the red geostationary orbit, it's going to perform a burn which is going to lower its periapsis into the atmosphere of the Earth. And that's basically what's going to allow it to come back to Earth and not become space junk, which is very important. Ariane 6, so they were talking about the Ariane 6 vehicle, and what's interesting about that, of course, is its comparison with the Ariane 5. And what makes this unique is that they're actually trying to downsize the vehicle a little bit in terms of its tons to orbit, and also the cost, because the main issue they're having is that satellites are getting smaller, so it doesn't really make sense to have this giant launch vehicle that has this huge payload delivery capacity. Instead, it makes more sense to build a vehicle that's more tuned to getting less mass to the geostationary transfer orbits and have it cost less. And that's kind of the idea behind the Ariane 6. And we should start to see that vehicle come online in the next year or two. And Ariane 5 will basically be phased out because she doesn't really have much work left to do. But we still have some work with the MEASAT and the GSAT-24 satellites. So we will continue to watch as this rocket goes on to orbit. It looks like we're getting near to the 9 kilometers a second point, and you can see that the rocket is continuing along the green trajectory, so things are still looking good.
The first satellites, and of course we'll be going live to the Jupiter room in Kourou. Just before, let's find out about the latest development on Ariane 6. We will have some images, and same job for you. Can you comment, please, all those images?
Yeah,
so here comes the, this is basically the Ariane 6 that they're going to be talking about. And yeah, this is basically the process that it goes through. It's really amazing that they're able to get this rocket, like, it goes basically by ship to South America. And if you think about it, like, there's not really much of like an industrial buildup in South America. So like moving these rockets to these places is really quite a challenge, I would say. So they have like special roads and special machines that they use to, of course, carry this around. And of course, the reason why they launched this from South America, because it kind of makes no sense to build a rocket, you know, in Europe and then send it all the way to South America. Like, that doesn't make sense. But the reason why they do it is because basically they're taking advantage of the location on the Earth, which is near the equator, which lets them get into this geostationary transfer orbit a lot easier. And here you can see the 2 solid boosters that will go on to Ariane 6. And they're basically testing the different pieces they will be using in order to be operating the whole launch complex. So basically all the ground equipment is being tested, and yeah. So this engine is going to turn off in just over 2 minutes here. 2 or 3 minutes. I might be off by a little bit. We need to get up to about 10 kilometers a second. So we're nearly there at 9.2 kilometers a second. And you can see we're still ascending along that green trajectory on the left-hand part of the screen there. And you can also see in this center view, I guess, the path of the rocket over the Earth. And it looks like we are somewhere in the Africa region right now. So you can see like the rocket's really traveled quite a ways in this 25 minutes that it's been thrusting. So really quite incredible. Oh no, we're losing the indicators again.
We are having a heavy summer ahead of us with a lot of challenges. 2 main milestones will certainly be, on the one side, the hot firing test of the new upper stage on the new test bench in Lampertshausen, Germany. And the second key milestone will be the combined test. Starting
We might be
here
testing in
Kourou.
Lamplhausen.
On ELA4,
Maybe.
we will have the full launcher on the pad, and we are all eager to look to that. Through the summer, we will consolidate a number of additional milestones, which will bring us to end September. And end September, we will, of course, be in a position to have more confidence and consolidate our planning towards the maiden flight and ramp up of Ariane 6.
So he mentioned Lamplhausen there in Germany, and this, of course, is the launch site where we might actually be able to test our rocket Transcendence. So it's kind of like a split facility where like half the facility is basically for Ariane Space, and they test their rockets there, and they'll also be, as he said, testing the Ariane 6. But there's also space there for testing some smaller stuff, and that's where ASTRA Bremen will be able to test their rocket, which might go to the Kármán line soon. So yeah, it's that spot, and there's another location in Germany that we're also looking at called DLR Trauen. But we'll see which one is best fitting for us. Yeah, but it's really cool that we might use the same facilities as the professionals.
They're working hard towards the preparation of the Vega C first flight, and this is now our next step, so we stay focused.
So we should have
so now it's time to go back and to stick to live, because we are a few minutes away from MEASAT-3d separation from Ariane 5. David, what news do you have from Kourou about this first separation that is about to happen?
Yes, it should happen in a few seconds. The launcher has now finished the maneuvers to give MEASAT-3d the correct orientation. And yes, in a few seconds, we should have a confirmation of the separation.
Which is a really important step.
It is indeed a very important step, yes.
Well, let me remind you all that MEASAT is the...
So we will have, before we have the separation, you will see that the engine has stopped, and it looks like that has just occurred because we see the velocity is going down.
MEASAT-3d is one of the most important stages of tonight's flight, isn't it, guys? Another one is when the satellite links up to the operator, and MEASAT will
So
be
it looks
looking
like the
forward to
separation is
momentum.
official.
Oh, they are clapping.
Yeah.
Where they can finally celebrate the end of the mission. David, for the moment, all the teams in Kourou seem to, there's thumbs up, they seem to be very happy.
All right, here we go.
Indeed, it's a very good moment for MEASAT, but the mission is...
Wow, look at this control room.
This is why we see in the Jupiter room, if you have people clapping...
This is like NASA-style control room right here.
So the launcher now will do a few maneuvers to release the SILDA, the level launch structure, and then after that it will do some additional maneuvers to release the second passenger today, GSAT-24.
So basically what he's talking about here is because of the way the Ariane 5 is designed, basically MEASAT was sitting on top of the satellite right here, but then the second payload is actually inside of this this cover. So basically they need to kind of reorient themselves, release the cover, and then they can release that second payload. So that's what's happening right now.
Even communication satellite mission undertaken by the New Space India Limited. So all teams, as we said, in Kourou remain focused. Among them, we have the CVI. Who are they? What role do they play in the mission? Let's watch. I'm not asking you the question. Let's watch, let's watch this report.
Je m'appelle Justine, j'ai 26 ans et ça fait 3 ans que je travaille chez Ariane Space maintenant. Et je suis ingénieure en analyse de mission et responsable CVI. Donc CVI, c'est un peu...
Once again, unfortunately, I do not speak French.
Immédiat.
But okay, we'll just so yeah, right now what's happening is basically this this upper stage is reorientating itself so that the second payload can deploy. And as I stated before, the upper satellite has already separated, MEASAT, so it's on its way, it's doing its thing, and it'll be connecting with the ground and establishing contact to make sure it's all okay. In the meantime, the second stage is going to do some maneuvers to spin itself in a slightly different orientation. It'll deploy this this black cover that it has over top of the satellite and allow that second satellite to be able to be deployed. That's the GSAT-24 satellite. It needs to make a reorientation because, of course, if it deploys this black cover in the same orientation, that will actually go and hit the MEASAT satellite, which we don't want. that could be dangerous and it could damage the parts of MEASAT. So instead, it's going to do some things to reorientate itself so that doesn't happen. So that should be happening in the next couple of minutes. And then we should have the separation of GSAT. And then they should be far enough away from each other that they shouldn't also run into each other, which would always be a concern, of course. Yeah, so just to give you an idea of where we are in the orbit, again, we are just at the bottom of this geostationary transfer. We're a little bit further now, so not quite at the bottom, but just a little further along this white trajectory. And of course, the destination is the top of this trajectory. But we're going to separate the satellites way down at the bottom here, and then they will kind of go all the way up to the top on their own. Just that's their path. They don't have to do anything to get there at this point. But they'll do an insertion burn at the very top, and that won't happen today. It'll probably be happening in 6 hours or so, and it'll be pushing itself into that geostationary orbit, which is this red line here. And to visualize that geostationary orbit, again, you can see it here. It's just an orbit which rotates at the same speed that the Earth rotates, which allows these two satellites to perform the operation that they were designed to do, which is basically sit in one spot over top of the Earth in the Malaysian and Indian regions to be able to service those regions for their communications. That's kind of the idea. So it should be a couple of minutes here, and we should see the separation of the GSAT-24 satellite, which was built by ISRO. All right. Okay, we're still talking to the operations team. The entire operations team at Ariane Space is French, so these people all are operating in French in the situation room, which is different than launches at other launchers, of course, because usually it'll be in English. But this is, of course, a European launcher.
She's talking to you, and we saw her in the report.
That's right.
David, I'm glad to see that
So
there
it
are
looks like the
women
cover's
and
off.
working in important positions within the space industry. It looks like we need some more, but let's get back to our mission in hand. Can you confirm now the injection orbit of the first satellite, David?
Yes, at this point, the CVI team has the information from the launcher on the exact injection orbit, and this information will be provided to our customer to facilitate the first connection that the satellite will establish with its ground stations.
So it's good to hear that we have a successful ignition.
For this moment with MEASAT to celebrate the success of the mission. Meanwhile, we have a couple of questions from you on the social network related to tonight's flight. And we have this one from Elon Muscles. It's a different one. The question is, blah, blah, blah. So I give you a sum up. When can we consider the mission of an Ariane 5 rocket to be over?
Yes, for our customers, Ariane 5 mission is over once the satellites have been released from the launcher in the targeted orbit. So this is what just happened for MEASAT. However, for us at Ariane Space, the mission continues a bit after releasing the satellites. We use the remaining propellants on the tanks to reduce the altitude of the orbit as much as possible. And then we depressurize the tanks to make sure there is no problem. and we basically turned down all the power and all the systems on the launcher. Basically, we shut everything down in a safe way.
I have a question.
So this basically, what he just described is the procedure that they do in order to deorbit the Ariane 5 upper stage. And that happens, of course, at the end of the mission. So once they've released all the payloads, that upper stage will float all the way up to the top of the geostationary orbit, and then it'll perform that deorbit burn with whatever propellant's left in the tank. And that will bring that periapsis down into the atmosphere, and they'll basically use the atmospheric drag to suck it back into Earth and have it crash in the ocean somewhere.
And to avoid falling back to 250 kilometers. And so this acceleration will be sufficient to stay at 36,000 kilometers all the time. So it will, at that point, be in geostationary orbit.
Okay.
And there he was talking about the orbital insertion burn that the satellites are going to make in order to get themselves up into that geostationary orbit. And that's basically what's happening when the satellites get up to the point where the white ellipse is connecting with that red circular geostationary orbit. So they have the MEASAT and GSAT-24 both have propellant and rockets on board to perform this injection burn.
Compare it to your hand could be the rocket.
The rocket, yeah.
And so when you release the ball, this is what happens when you release the satellites. Your hand stops pushing the ball, the rocket stops pushing the satellites, but the satellites continue moving up, and this is how they will move up to these 36,000 kilometers, which is the apogee of the orbit.
Yeah.
A great comparison. Thank you, David. Well, we are now less than 2 minutes away from the separation of GSAT-24, the Indian satellite manufactured by ISRO. So if we look up at the screen, what information is it giving us, David? Flight info, speed, altitude, height. Can you say that everything is normal?
So you can see there on the screen.
The launcher is doing its last maneuvers to put GSAT-24 in the right orientation.
You can see it's spinning. It's spinning to get itself into an orientation that doesn't point towards MEASAT.
Above the Indian Ocean, just not very far from India, and with a speed of, close to 7.3 kilometers per second.
So does this...
And of course, it's doing that so that we don't have a collision between the satellites, which could be possible if you deployed it in the same direction as you deployed the first one.
For the confirmation of the acquisition of a signal from the customer.
And at what time will this happen?
Well, this should happen about 10 to 12 minutes after the separation of GSAT-24.
All the teams they are waiting patiently in Kourou. They must be on tender hooks. This is a huge moment for them.
Yeah, we're seconds away from the second separation.
Just waiting
here we go. The second separation should be happening pretty soon.
We have the confirmation that, as you see in the images, the launcher has finished the maneuvers, and therefore the separation will happen shortly.
So you have the confirmation yet? Because I'm waiting now until the
There we go.
Oh, brilliant.
There we go. Separation.
So this is the DDO, and he has just confirmed the separation of GSAT-24. This is great news, and this is why we can see all those people clapping and
applauding the success of the mission.
So it looks like we have a fully successful launch.
This confirmation really
fantastic.
Important,
absolutely fantastic.
And why are we waiting for a signal acquisition?
Yeah, so the satellites after
so
separation, they need.
We have a fully successful mission now.
To switch on their systems.
Ariane 5 has successfully got into a geostationary transfer orbit, and it has deployed the MEASAT satellite. And then it did some maneuvers to eject that cover that is covering up the GSAT-24 satellite. And then it finally deployed that GSAT-24 satellite. Now, both of those satellites are going to drift up to the apogee of the geostationary transfer orbit, where they will perform an orbital insertion burn that goes into that geostationary orbit that they want to go into. And that way they will always be at the 36,000 kilometers altitude, hovering over the single point where they want to basically service. And basically that's going to be for the Indian and the Malaysian markets, and basically those satellites will just sit right in their parking orbits above those positions. The Ariane 5 vehicle, the upper stage, will also drift up to that geostationary transfer orbit, up to the apogee. But instead of putting itself into a geostationary geostationary orbit, it's going to perform a deorbit burn that's going to reduce some of its velocity and basically point it into the direction of the Earth's atmosphere. And that will essentially deorbit the Ariane 5 upper stage and allow it to come back and crash into the ocean some point in the future. It doesn't happen immediately because it takes quite some energy that you have to remove in order to get it out of that geostationary transfer orbit. So it could take some days or some weeks, but essentially it will be removing itself from orbit and getting rid of any space debris or junk that it would create. So it's not leaving anything in orbit as junk. So this is a fully successful mission. That's good to see. Ariane Space, of course, doing it again, adding one more to their reliability record. We're looking forward to the upcoming missions of the future for Ariane 6. This vehicle will be coming online sometime in the near future, so definitely stay updated about when the first launch of that will be. It's supposed to be in 2022, but of course we you have to take a grain of salt with that, because when you're developing new rockets, things get pushed back quite quickly and quite easily. Yeah, thanks for joining me with this launch and this journey. I hope you guys can continue to check out our channel and check out our mission, which is to launch a rocket into space. We're a student amateur rocketry group, and of course we're trying to achieve this milestone, which would be the first European amateur rocketry group to do this. So we're trying to get our names into the record books, as it would say. And yeah, if you want to help us out on the journey, check out the links down below. It's links to our website and to some more material about what we're doing and what our mission is. And yeah, we hope you can join us on the journey. Thanks for joining along, and I hope you continue to expand your horizons.
It's always special. It is always the same. It's different, one launch from the others.
Unfortunately, I have only seen once this launch from outside. Usually the other launches I have been inside the control room, but yes, it definitely depends on the conditions.